Welcome class to your first lesson in Algebra 2. We're going to have a great year and I'm really excited for the new structure. I think it's going to benefit a lot of people. So for our first lesson today, we're going to go over some topics that were covered in Algebra 1, but we're going to spend some time with them because it's been a while since we've had Algebra 1. Today let's actually look at simplifying, evaluating, and solving. And in the book that you have, it's sections 1, 2, and 1, 3. We're going to look at simplifying, evaluating, and solving. Now, ideally, with just those words written, you could think of examples to go with each of them. Write an algebraic example of simplifying, algebraic example of evaluating, and an algebraic example of solving. What happens a lot is, well, to be honest, a lot of ways that teachers can tell if a student really has an understanding is when there's a problem that comes up that says to simplify, but they start doing solving procedures, okay? So it's important to know in what situations each one applies. Let's begin with some examples, okay? Our instructions are to evaluate. And for our first example here, we've got an algebraic expression of negative 4x squared minus 6x plus 11. And we want to evaluate this when x is equal to negative 3. Now, this is a quadratic expression here. Quadratic because it's got an exponent of 2, or a degree of 2. We have 3 different terms here. Sometimes you can combine like terms to simplify something. In this case, you cannot. None of these are like terms. But our instructions say to evaluate. And what they've done is they've told us that x is equal to negative 3. So what we get to do is we get to substitute negative 3 in for x at each occurrence. So I want you to be very precise when doing this. This is a negative 3. And whenever we're dealing with negatives and I have to evaluate something or substitute, I'm really particular about my parentheses. It's easy to do the wrong operation without them. So I'm strictly going to just rewrite this. But in place of x, I'm going to write parentheses negative 3 squared minus 6 times parentheses negative 3 plus 11. Now from there, it's an order of operations problem. PEMDAS, remember? PEMDAS can help you out. Ideally, you do this without a calculator. You do it step by step and you follow the processes. A lot of your calculators will do this for you, so I don't want to be deceitful about that and tell you you can't use a calculator here. Some calculators are very good with their displays, and you can enter this all in and hit a button. But you're missing out on a little bit of the thought process. So in my notes, I'll always take things step by step and I'll perform the order of operations. I may combine multiple steps into one, but I'm still going to go through those order of operations. For example, parentheses, nothing to do inside those parentheses. Exponents, do I have any exponents? And I do, so I'm going to perform that operation first. From there, PEMDAS, we've got multiplication and division, addition and subtraction. I'm going to do PEMDAS with the exponent first, but then I'm going to go ahead and perform the multiplication operations as well. So negative 3 squared is going to be 9. Negative 4 times 9 is negative 36. Think of this, I like to think of this as a negative 6 times a negative 3, and a negative times a negative is a positive 18. And from there we do addition and subtraction from left to right. So negative 36 plus 18 plus 11. So negative 36 plus 18, that's 18 plus 11. So we're looking at 29. Does that look good? I actually made a mistake. First day, oh my goodness. What was my mistake there? Negative 36 plus 18 is 18, but it's a negative 18, isn't it? So what we actually have is a negative 18 plus 11 and a negative 7. Now with evaluating, the best way to check your answers would be just to kind of go through your steps and see if there's any mistakes. It's not like with solving where you can plug it back in and see if it satisfies the equation given. You're not given an equation, you're given an expression. All right, let's move to a second example here. Five x multiplied by x minus 2 when x is equal to 6. And again, our instructions are to evaluate. You're allowed, as long as you do it accurately, you're allowed to simplify within this problem. You could go ahead and distribute that 5x times the x, the 5x times the 2, and then evaluate what's left over. I'm going to simply go directly to the substitution step and keep everything as it is. But you've got some options. From there, it's order of operations. So I'm going to do my parentheses first. That'll give me a 4. And then I've got a whole lot of multiplying to do. Some people may look at this and think that the 5 distributes, but no, if it's all multiplication like this, there's no addition or subtraction there. You don't distribute, you just do it in order from left to right. So 5 times 6 is 30. 30 times 4 is 120. So that wraps up a couple examples of evaluating. Well, if you don't mind, we'll move on. Like I said, review from Algebra 1, but it's been a while. For our third example, the instructions are simply simplify. And we have 3 times y plus 2 minus 4 times y minus 7. And we're asked to simplify. Well, for simplifying, we typically do PEMDAS, order of operations. So parentheses. Can I simplify these parentheses? I cannot. I cannot simplify what's inside the parentheses, not like terms. Then from there we go to exponents. We don't have any. And then we've got multiplication. We do have some multiplication here. And because we're multiplying a sum, we are going to use the distributive property. And I like to draw my arrows in there. Now, what can be a little bit tricky about this is we're subtracting the whole, we're actually subtracting the whole thing. They're connected by multiplication. So I'm going to rewrite this real quick as adding the opposite. And I'm going to make sure to distribute that negative with me to get an accurate result. 3y plus 6, and then plus, and then it'll be negative 4y. So I'll go ahead and write minus 4y. Negative times a negative, 28. Now from there, we combine like terms. We've got like terms finally. We've got a 3y and a negative 4y. If we simplify those, we'll get a negative 1y or simply a negative y. So a lot of teachers don't like this, but I kind of mark them out. They didn't actually go away. They're still there, but it's just kind of keeping track. I'm noting what I've done already. From there, I've got like terms of 6 and 28 to make positive 34. You could write this as 34 minus y. That would be equivalent. But we want to be in the habit of writing our answers in a standard format where the variables come first, the constants come at the end. If you have different variables with different degrees or exponents, they would go down the line. You'd start with the biggest exponent, the biggest degree term first, followed by the next lowest, and work your way on down. And let's do another simplify. Again, with checking on evaluate and simplify, it's kind of, there's not a real easy way to check other than kind of reviewing your steps, watching your signs and things like that. So we're still in the simplify realm, and we've got an expression here of 2q squared plus q minus 7q minus 5q squared. This is a quadratic. This one ended up being linear. This is a quadratic from the beginning. We've got a degree of 2. But notice we've got some like terms, don't we? We've got q squareds that are like terms. We've got q's that are like terms. So let's start off by simplifying those. 2q squared minus 5q squared is going to be negative 3q squared. The q squared part does not go away. There's 2 of them, there's 5 of them. What's left over is 3 of them, but they're negative. So negative 3q squared. Again, I'm going to kind of mark these out just to show, just to keep track. From there, I've got a q minus a 7q. And q minus 7q, it might help you to realize anytime you've got a variable, it's got a leading coefficient. It's got a coefficient, I should say, of 1. So if you've got 1q and you subtract 7q's, you've got 6 q's left over, but they're negative. So I'm going to write negative 6q. From there, it's tempting to combine these together, but not so. To be like terms, they have to have the same degree. So we are set. And it's written in standard form. Highest exponent first. Now finally, class, let's end this lesson, or kind of review, I should say, probably, with some solving. Simplifying, evaluating, solving. If your instructions say to solve, you're actually determining x's value, the variable's value. You're actually going to figure it out. So what you have is an equation. And our equation is 4/5 x plus 8 equals 20. Now this is a linear equation because it's got a degree of 1. It's linear, not a quadratic. And to solve this, we approach it differently. Oftentimes you can simplify within a solving problem, but these are not like terms, so we can't really simplify it. But we can solve it. And to solve it, we're going to do inverse operations to isolate, to get x by itself. Now what's interesting about this is you could decide, well, I got to get rid of this 4/5, so I can multiply by something to undo the 4/5, or you could divide by 4/5. But we typically don't do the multiplication first. Now the reason why is because if I multiply or divide, it has to distribute across addition, and people often, to be honest, forget that part. So what you'll see a lot of teachers say in this instance is to undo the addition and subtraction first. And then when you undo your multiplication, there's only one thing on each side that it impacts. But you can actually get the same answer by undoing this part first. And I don't know, I might show you that in class if you're curious. But I'm going to put a little dot with the x. I want to get that by itself. I'm going to start out by minusing or subtracting the 8. Subtraction is the inverse operation of addition. So we get 12. 4/5 x is equal to 12. Yes, you could divide by 4/5, but I'm I'm never going to do that. I don't like dividing by a fraction. Instead, it turns out the equivalent operation of dividing is multiplying by the reciprocal. So I'm going to multiply both sides by 5/4. Now, why does that help me? Because when you multiply something by its reciprocal, you always get 1. 4's divide out, the 5's divide out. And we're left with 1x, or just x. On the other side here, you could grab a calculator, but I'm not. I'm going to make this a fraction, and I'm going to cross simplify. 4 goes into 12 3 times, multiply straight across. I get an answer of 15 over 1, or just 15. Now, the nice thing about solving problems is you can check your answers. You can put 15 back in here, simplify it, you'll get 12 plus 8 is 20. And you know at that point you've checked your answer and you're good. You're set up nice. Okay, let's do one more. Wrap this up, one more solving. We're just kind of getting you back in the groove here with these problems. I wouldn't say they're easy problems, but they should be familiar. For our last example, let's do our instructions are solve. 3 times 5x minus 8 is equal to negative 2, negative x plus 7, minus 12x. Okay, now there's a few different things about this. We've got multiple variables. So the same variable, which is good, but we've got multiple of them, so it's kind of hard to isolate one of the variables. Also what we have is we've got some simplifying that we can certainly do here. And that ought to make the problem more tolerable. Something that people are tempted to do is they realize that they've got to get the x's back together. We've got to get these together. But they do that as their first step here. Well, that's actually against the math laws. Now, the reason why is because this 5x is actually being multiplied by this 3. So you can't just subtract a 5x over. You would actually have to subtract 15x over to make it right. And this x is actually being multiplied by the 2, so you can't move that around. You don't want to undo things. Also, you've got this additional x here. So let's actually take some time just simplifying both sides and then see if it's a little bit easier to deal with. On this side, I'm going to simplify this by the distributive property. Whoops, minus 24. Distributive property. You stop at the parentheses there. It's just this times this. Negative times negative is positive 2x. Negative 14. I'm going to go ahead and bring down the rest of it. There's no more simplifying I can do on this side. This expression can be simplified more because we have like terms there. So I'm going to rewrite this, leave it alone. And a 2x minus a 12x is going to be 10, so negative 10x. Again, I'm marking it out just to stay updated on where I'm at. And I've still got this minus 14 left over. From there, to solve for x, I need to get this as 1x, not 2 of them. So typically what people do is they move the lesser of the 2. And what that does is that keeps you in the positives, which people prefer. You don't have to. You could move this 15x. But if you if you do an inverse operation of subtraction, you would add a 10x. And with addition and subtraction, you just got to do it once on both sides. Some people already kind of know where we're going with this. They would add the 10x over to get the x's on this side, and then they learn to get the constants on the other side, so they would go ahead and add 24 over. You can do that, but I'm kind of taking things one step at a time. 0 minus 14 is negative 14. And now what you have here is a linear equation, and it's a two-step equation. If I were to divide the 25, I'd have to distribute it. I'd have to go to everything, have to distribute it. So I'm not going to do that. Instead, I'm going to add a 24, keep my equation balanced. 25x is equal to 10. Divide by 25. Divide by 25. 25 doesn't go into 10 completely, so I know my answer is going to be just a fraction, but it's a fraction that reduces. There's a 5 multiple in here, there's a 5 multiple in here, they'll divide out to make 1. So what we're going to have left over is x is equal to 2/5. A lot of your calculators will simplify that as well. If you enter that into your calculator, it'll give you either a decimal, or if it's really smart, it'll give you a fraction. We prefer fraction answers, okay? If a problem starts out without any decimals, we expect our answer to be without any decimals. So whenever you get a decimal answer, and I'll be checking, especially at the beginning of the year, to make sure you're squared away, but we prefer the fraction answer. The thing about it is decimals are often rounded, and we have an exact answer here, and we want to express it as an exact answer. So decimals kind of, or fractions alleviate that confusion. Hey, thank you so much for watching, and practice this. It's been a while, okay? It's been a while, so you're going to need to practice. Thank you so much.